So I just have one more example here before the discussion questions. And in this example, the base of the solid is a parabolic region between y equals 0 and y equals 4 minus x squared. Okay, so that's our base. And in this case, the parallel cross sections are perpendicular to the y-axis, and they're squares. Okay, so the cross sections are squares. Okay, and we want to find the volume of the solid. Looks like I'm missing a period there. All right, so let's first of all just visualize what the base looks like. All right, so I'm just going to draw the axes here. And so what we have is a parabola. It's upside down, right? Because it's we have a -1 leading coefficient. And so what it's going to look like is it's going to have a vertex up here when x is 0, you know, y is 4, and then it's going to come over in the x direction plus and minus 2. So -2 and +2. All right, so here's what our parabola looks like. And this is the base of our solid. Okay, so this is y, this is x. And, okay, so y is equal to 4 minus x squared. That's the equation that defines our base. And now let's try to lay that down, and so we can show those cross-sectional those cross sections, those square cross sections. So I'm just going to draw my x-axis the same way, only I'm going to try to lay down the y-axis so it looks like it's three-dimensional. And so then we have this parabola, which I'm going to try and draw like that. Okay, going from -2 to 2. And then we have these cross sections that are squares that stick up. So I'm just going to draw the one on the end. It comes up and it's a square, so they have to come up by 2. Not very. All right. So you can see, okay, that's kind of what our squares look like. All right, and then they're just going to get smaller and smaller, right? We're told that these cross sections are perpendicular to the y-axis. Okay, so we've got that, and then they're going to have some little thickness to them, right? So I could actually draw this with some thickness. If I could draw straight lines, right? It looks really bad. Okay, you get the idea, hopefully, that, you know, we've got these square slabs that we're going to just stack up along this base, and they're just going to keep getting smaller and smaller. So, you know, there's going to be a square up here, which I could kind of draw like that. So there's going to be another square that sticks up there, and they're just going to keep getting smaller. So it's going to kind of curve down to the tip here. You know, I could actually draw, you know, kind of what this other edge looks like. Oh, it's kind of hard to see what it's going to look like in 3 dimensions, but hopefully you get the idea here of what the solid kind of looks like. So this is y and this is x. Okay, so now what does each cross section look like? It's just a square. Okay, and so we're just going to come over from the y-axis a distance of x, right? And that x is going to vary as we move up the y-axis, right? Because it's going to be defined by that parabola. So the side is going to be 2x, and so the area of each cross section is going to be 2x squared, so 4x squared. All right, so let's think about these cross sections are perpendicular to the y-axis, so our thickness is delta y. So we want to integrate integrate with respect to y, okay, because we're going to add the slabs as we go up the y-axis. All right, so I really want this to be in terms of y. So I need to rewrite my equation here. So if y equals 4 minus x squared, then x is equal to the square root of 4 minus y. Okay? And so if we put that into our equation for area, squaring x, we square the square root, so we're going to get 4 times 4 minus y. All right, well that's nice. So now let's add up all these little square cross sections, and we're integrating in the y direction. So we're going to integrate from 0 up to 4. Okay, and we're going to integrate this area, the area of each of these squares. So 4 times 4 minus y dy. Okay, now let's see. So we're going to get 4, and then the integral of 4 is 4y. Integral of y is 1/2 y squared from 0 to 4. All right, so now it's just some arithmetic. We're going to get 4 times 4 times 4 is 16. Plug in this, we get 4 squared is 16 divided by 2 is 8. All right, so basically 4 times 8, which is 32. So the volume of this solid constructed from all these squares, cross section where the cross sections are all squares, is 32.